So for this question on plane geometry, I will say this one is quite an easy one. Okay, because the diagram is quite plain, and there's a pair of parallel line, and then they actually gave you two tangents. So at one glance, right, you should be able to detect tangent from an external point. And then of course, with the parallel line, you should be making use of the property of parallel lines subsequently in any of the parts. Okay. And then, of course, because there's tangent, right, you should relate back to tangent chord theorem. So all this should come to your mind when you look at the diagram, when you look at the info given to you. So the way to approach it again, like I always will tell you, you can do it by algebra method. So in this case, right, the first one, I'm supposed to prove triangle ABC to be isosceles. So the property of isosceles triangle can either come in the format of a length, or it can come in the format of an angle. So obviously, right now, I do not have any information about the length, so I shouldn't be trying to prove it by length. I should be trying to prove it by angles. So out of the three angles, I'm hoping to get two to be the same, and then that will be the base angle of the isosceles triangle. Okay, so you can do some planning first. So the first planning that I will see, right, will be like I mentioned just now. I should have angles from tangent from external point, and then this will be an isosceles triangle. So for the property, angles from a tangent from an external point, that will have created these two angles to be the same. Okay, so I will not be writing out. I will be explaining. You can refer to my worked out answer. It will be exactly like what I wrote. So I started off with tangents from an external point, and it gave me a pair of similar isosceles triangle here. Then subsequently, if I take a look, this angle is made by a tangent and a chord. So this angle will be the same as this angle. So angle ABC is also equal to K because of tangent chord theorem. So I started off with the tangent from an external point, and it gave me an isosceles triangle. So that two angles are supposed to be the same. And from there, I managed to see a tangent chord theorem. So I gotten K as one of the angle inside the triangle. So another one will be the isosceles triangle here. Not isosceles triangle, sorry. The alternate angle. So this green one is equal to this due to alternate angle. So if you are quoting alternate angle, do remember to write which pair of parallel line is responsible for this alternate angle. So if you look, I started off with tangent from external point. That's one property. I have a tangent chord. I have an alternate angle. So if you write that down and write a concluding statement to say that these two are eventually the same, so that makes ABC an isosceles triangle. So that's it. Three properties, and you get the 4 marks here. So that's pretty easy. Okay, then the subsequent part, if you already built or already have a subsequent a set of algebra, we try to carry on with the set of algebra. So in part B, I'm interested to prove that BCA is equal to CTA. So you keep the algebra first. Okay, so we try to locate which are the two angles here. So BCA is this angle. Okay, CTA is actually this angle. Okay, so you can follow up with whatever that you have written in part A. So whatever that you written in part A, if you take a look here, because part A, you already set up the algebra. You already accounted why these two are the same. So you can just apply angle sum of triangle. So in this angle will be 180 minus k due to angle sum of triangle. So you build on the algebra that you already done up in the first part. Okay, so similarly, the same thing happened here. Because you already proved that it's an isosceles. So again, you're going to apply angle sum of triangle. So this angle is also 180 minus k. So you do not need to explain why you already have gotten it as an isosceles because you already explained in the first part. So you just need to quote that this is angle sum of triangle. And because they got the same algebra, therefore they are the same. So I will say this question is quite an easy question on plane geometry. So it's a giveaway question. So you can use this to recap the tangent chord theorem, tangent from an external point, and the use of algebra in the proving of plane geometry.